Greetings everyone, I am Ronald Sarmiento with my co-reporters Regine Tolentino and CJ Corpus. We are from Group 2 and we will be discussing science and technology and nation building. But first, at the end of this section, students will have number 1, the basic knowledge of the National Development Agenda and other policies of the government. Number 2 is background in the development of science and technology in the Philippines. And then the third one is view of Filipino inventors and their contributions to science. Now let's talk about the Science and Technology Agenda, the DOST Strategic Plan. First one is Innovation Stimulus. It is the will to innovate something. Number 2 is Technology and Adoption Promotion and Acceleration. This offers what no one is offering. It also boosts revenue streams and while providing some value. Number 3 is critical mass of globally competitive science, technology, and innovation or STI, human resources development. Here, the point at when it becomes self-sustaining and no longer needs additional investment. Number 4, productivity and efficiency of communities in the production sector, particularly micro, small, and medium enterprises or MSMEs improvement. Number 5, resiliency to disaster risk and climate change assurance. Here, we need the capability to recover quickly from difficulties with disaster risk and climate change. Number 6 is inequality in STI capacities and opportunities reduction. It is the unjust distribution of opportunities. Number 7, effective STI governance achievement. It is the successful in producing the intended results. Now let's talk about the DOST 11-point agenda. What is the DOST 11-point agenda goal? It encompasses the strategies and to be implemented to achieve the vision and desired outcomes. Number 1 is pursue research and development or R&D strategies to address pressing national problems. Example of pressing national problems is climate change. Number 2, conduct R&D activities to enhance productivity and improve management resources. We should organize R&D activities to enhance productivity and improve management resources. Number 3, engage in R&D to generate and apply new knowledge and technologies across different sectors. We should participate in R&D activities so that we can apply knowledge and technologies across different sectors. Number 4 is strengthen and utilize regional and provincial R&D capabilities. We should strengthen and make use of the regional and provincial capabilities. Number 5 is maximize the utilization of R&D results through technology transfer and commercialization. We should maximize the use of R&D results so that using technology transfer and commercialization. Number 6 is develop STI capable human resources and build a strong STI culture. We should expand our STI capable human resources so that we can build a strong STI culture. Number 7, upgrade STI core facilities and capacities to advance R&D activities and expand S&T services. Number 8, expand STI assistance to communities and production sector, particularly the MSME. Here, we should become more extensive so that we can provide more assistance to communities and the production sector. Number 9, provide STI-based solutions for disaster risk reduction and climate change adaptation and mitigation. Here we should make more available solutions for disaster risk reductions and also the climate change adaptation or mitigation. Number 10, strengthen industry, academe, or in short for the academic environment, government and international STI collaboration and cooperation. And then the number 11 is enhance effectiveness of STI governance capabilities. Next is the consistent with the regional agenda, the Millennium Development Goals, and accordingly, the Sustainable Development Goals of the United Nations, the Harmonized National R&D Agenda 2013 to 2020, a product of continuing process of consultations among DOST, stakeholders, and the other partners from the academe, industry, people's group, and government agencies, initiated years ago by the Presidential Coordinating Council for Research and Development, or PCCRD, addresses the pressing issue of poverty, promotes sustainable development and inclusive growth, and tackles climate change issues.
Science in industrial development. So science in this industrial development is being the foundation of development in agriculture, in industry, and even in health. It is the vital key to the country's industrial resources. So, ang pagbuo nito ay mahalaga in helping to bring about a more stable and progressive economy. So, the development and expansion of science have been brought about because of the man's curiosity for the truth. This hunger of the mind mentality, a manifestation of his great intelligence, has been since the dawn of history the instrument to his understanding of the environment. So, the hunger of the mind referred to the outright painful sensation of hunger caused by insufficient funds. So, hunger of the mind was related sa trauma in composing feelings of depression and hopelessness. Both forms of hunger may be a physical manifestation of structural and interpersonal violence. So next is the Harmonized National R&D Agenda. So the Harmonized National R&D Agenda is the outcome-based agenda where all R&D programs and projects to be funded by the government are envisioned to contribute to the attainment of the at least three of the President 5 key results areas, particularly responding to poverty reduction and empowerment of the poor and vulnerable, rapid and inclusive, sustained economic growth and integrity to the environment and climate change adaptation and mitigation as indicated dito sa figure 1. So next, so next is program area 1. So sa program area 1 ay ang poverty alleviation and inclusive growth. So the major outcome of this is expanded and strengthened the socio-economic development of the country, particularly the poor segment of society, vulnerable and marginalized through science, technology, and innovation. So the Rnd priorities areas under focus area 1 is composed of food and nutrition security, countryside development, competitive industries, social services delivery, and last is biodiversity conservation and sustainable development. So, ang expected outcome for each of these areas ay naka-indicate dito sa table 1. So, the expected outcome for food and nutrition security is quality, safe, and affordable food for all at all times. So, next is the expected outcome for countryside development is more farmers, fisher folks, and MSMs developing and producing competitive and world-class products and services. So next is competitive industries. So the expected outcome is uh, More industries enabled by the state-of-the-art R&D facilities, technologies, and science-based policies, moving up the value chain and attracting foreign direct investments. So next is the expected outcome for social services delivery is innovative, accessible, affordable, and efficient social services for all. So next is the expected outcome for biodiversity conservation and sustainable development is science-based management of aquatic and terrestrial ecosystem for sustainable resource development and utilization. So next is the competitive industries. So sa competitive industries, the following 8 industries where science, technology, and innovation interventions can create major impacts have been identified. So ang expected outcome for each of these areas are indicated dito sa table 2. So the expected outcome for semiconductor and electronics is competitive Philippine companies capable of undertaking R&D and designing and producing quality products for local and global market. So innovation-friendly business environment capable of attracting foreign direct investments. So the expected outcome for healthcare is a global leader in healthcare capable of sustainably developing products from the country's rich biodiversity and offering services that contribute to achieving universal healthcare. So next is IT-BPM. So the expected outcome is a global leader in information technology, business, process, management services directly employing more Filipinos, including those in the countryside. So next is agriculture. So the expected outcome for agriculture is world-class and highly productive agriculture enabled by science-based know-how and tools. So fifth is mining and minerals processing. So the expected outcome is sustainable mining and minerals processing industry producing high-value products through green technologies, responsible practices, and science-based policies. So sixth is transportation. So the expected outcome for transportation is a modern, cost-effective mass transport system through enhanced design, manufacturing, supply infrastructure, and support capabilities. So second to the last is manufacturing. So the expected outcome for manufacturing is globally competitive and robust manufacturing industries. The examples are food processing, automotive parts, tool and die, uh, chemical, textiles and garments, and furniture that generates high-quality jobs, products, and services through technologies, capabilities, state-of-the-art R&D facilities, quality infrastructure, and science-based policies. So last is metals and engineering. So the expected outcome is globally competitive metals and engineering industry capable of producing innovative and quality products for the local and export markets. So next is social services delivery. So on social services delivery, the following 9 areas have been identified where S&T interventions can contribute significantly. So the expected outcomes for each of these areas are indicated dito sa table 3. So first is healthcare products. So the expected outcome is world-class healthcare products and services developed through science-based know-how and innovation to achieve universal healthcare. Second is nutrition. So the expected outcome for nutrition is elimination of malnutrition through innovation and science-based technologies, products, and services. So third is potable water or sanitation. So the expected outcome is safe, clean, affordable, and reliable supply of water for communities. So next is education. So the expected outcome is highly skilled and globally competitive Filipinos educated and trained through innovative and ICT-enabled learning methods and systems. So fifth is energy. So the expected outcome for energy is efficient, sustainable, and reliable energy supply for all through innovative and green technologies and science-based policies. So sixth is traffic or mobility. So the expected outcome is improved mobility of people and goods through efficient and intelligent transport system. So seventh is environment and pollution control. So the expected outcome is clean and hazard-free environment for all through innovative and green technologies and science-based policies. So eight is connectivity. Connectivity is the expected outcome is affordable and reliable broadband internet for all. So last is the e-government. So e-government is world-class e-government system and practices. Next, next is program area 2. So the program area 2 is climate change mitigation and adaptation and disaster risk reduction. So the major outcome is safe disaster or climate change resilient infrastructure and communities empowered by science-based meteorological, hydrological, and geological information, climate change scenarios with associated impact assessments, and decision support systems. So science, technology, and innovation has become the core of solutions in terms of addressing the impacts of climate change and disaster risk. This agenda supports the following areas that create science-based approaches to mitigate, adapt, and reduce impacts of climate change and disaster risk. So, first is innovations in weather and flood forecasting and climate change modeling. So the expected outcome is timely delivery of accurate weather-related information, flood forecast, and climate projection and services, improve climate change impact scenarios, accurately predicted and simulated disaster costing phenomena, and empowered partners to lead in reducing risk from weather-related hazard down to community level. So second is water security, water resource, water resource assessment and management. So the expected outcome is water security through science-based technologies and policies for water resource assessment, conservation, and management in the light of climate change. So third is climate change resilient agriculture. So the expected outcome for this is adaptive and resilient agri-aqua ecosystems through innovative and green technologies and science-based policies. So fourth is climate change mitigation. So the expected outcome is reduced greenhouse gas emissions and decreased carbon footprint through innovative and green technologies and science-based policies. So next is urban planning and hydrological data set. So so the expected outcome is S&T based planning, optimal use of land, and efficient water management. So sixth is disaster risk reduction. So the expected outcome is adaptive and resilient infrastructure and communities equipped with accurate and scientifically validated information on natural and man-made hazard and disaster risks. So last is the adaptive ecological systems. So the expected outcome is climate change resilient ecosystem and communities and inclusive, sustainable economic growth as a result of S&T-based management and development decisions that are founded on enhanced knowledge and understanding of the complex dynamics of terrestrial and marine ecosystem as they respond to changing climatic conditions. So next is the benefits of science. So the benefits of science is allows us to develop new technologies, solve for practical problems, and make informed decisions, both individually and collectively. So because its products are so useful, the process of science is intertwined with those applications. So new scientific knowledge may lead to new applications. So next is well-endowed Philippines. So alam naman natin na ang Pilipinas ay mayamang pinagkalooban ng natural resources as well as manpower resources. So bilang isang pangunahing agricultural na bansa, karamihan sa mga tao ay umaasa sa matabang lupa para sa kanilang kabuhayan. So using methods that have remained unmodernized so that agricultural production could hardly cope with the necessary and increasing requirements for decent food, shelter, and clothing. So the Maria Cristina hydroelectric and fertilizer plants of the National Power Corporation and shipyards and iron and steel mills are a good example of government-supported scientific marvels were supposed to spur the industrialization of the country. Such private ventures as the Superior Gas Company's Big Caustic Soda and Chlorine Plant, Marcellus Steel Mills and Tire Plant, and the Caltex Gasoline Refinery in Batangas. To cite a few were local pioneer industries that deserve special attention. So next is the sparring industrial research. So plans laid out for the economic development of the Philippines are now being implemented. These plans include rehabilitation and development of the principal agricultural industries, the development of new industrial projects, the rehabilitation and construction of commercial transportation and communication facilities, and the expansion of vocational and technical courses in the country. So the programs also include sending of Filipino fellows and scholars to some other countries for further studies, specializations, or observation, mostly in the field of science and technology. So the incentives for the growth and development of local industries and the eventual well-being of the state and her people are provide for. So that's all.
So next is scientific research and economic development. So ano nga ba ito? First, ano ba yung scientific research? So ito ay isang study or investigation ng mga bagay-bagay. It provides facts or scientific information. And second is ano din ba yung economic development? Yung economy is yung wealth and resources ng isang country. And development, alam naman natin na ang paglago or pag-improve. So, ito ay ang paglago ng ekonomiya. So, next is, since the middle part of the 20th century, a revolution has taken place in the economic thinking of underdeveloped states. No longer are these countries just satisfied with maintaining a few agriculture export industries. some subsistence agriculture for home consumption, and the importation of most consumer goods. The hard lessons of the past have been shown that this country that unless fundamental and massive change in the structure of their economies are undertaken, they have little hope for raising production, increasing employment, and improving the standards of living of the marginalized masses. Thus, economic development, with the emphasis on industry, has become the cornerstone of the economic policy of the underdeveloped countries, including the Philippines. So, nandito is about agriculture, that in some countries, for consuming lang, but they are considering na mag-export. Tapos, ang nangyayari, nag-i-import pa sila. So, yung potential nawawala. And alam naman natin na Philippines, we have high potential of doing so. But we are not doing it. It can improve employment and production that will result na yung gaganda nga yung buhay ng mga tao. But we can't do it without economic development. Di naman siya agad-agad magbubunga, kaya we need a plan. So, the success of any program of economic development largely depends on the care and the wisdom with which such a program is prepared. Tremendous amount of initial preparatory work has to be undertaken and assessed to coordinate the supply and demand of raw materials, manpower, structure costs, and foreign exchange including local currency, requirements, price structures at home, abroad, and other details should be considered in the evaluation of the project is feasible and worth undertaking. So, ayun nga, kailangan ng care and wisdom para mag-succeed dito. Kailangan din ng tremendous amount of initial preparatory work para mangyari din to. So, next is, these research studies cannot be isolated from one another for all sectors of the production and consumption, including export and import. Fiscal and monetary policies must form part, plan, and be integrated into the development program. Both in the preparation and implementation of the program, scientific research must play an integrated part. So, para sa lahat ng sectors ng production at consumption, kasama ang export at import. Yung fiscal and monetary policies ay kailangan maging part ng development program para sa preparation at implementation ng program, and scientific research is needed. So, some people are of the belief that development can be achieved at the same time in all sectors and that is neither desirable yun nga, nor practicable. Prepare a development program based on system priorities that will give certain sections specific advantage over others. Those who fail to consider obvious scarcity of the resources such as raw materials, manpower, and capital, we should definitely place a limitation even in highly developed states, and which are certainly of high importance in underdeveloped areas. Considering the scarcities of resources, blatant mistake in planning would have more serious effects in the Philippines and the other underdeveloped countries, and should therefore be carefully avoided. It will be stupidity or to encourage projects whose technical, economic, and social justification have not been truly studied. So ito nga, considering na sa Philippines nga, considering these scarcities of resources, blatant mistake in planning would have more serious effects. So ayun, nangyari na to kaya kailangan wag na mangyari para magkakaroon ng much more serious effects. So nakalagay din dito, it will be stupidity to encourage project whose technical, economic, and social justifications have not been truly studied. So yun nga, kailangan truly studied and truly planned nga yung mga ginagawa natin. So next is, ayun, the sad past of the past has exhibited that in the general thrust for development, projects have been launched which cannot survive open steep competition in the world market because of the lack of raw materials, the difficulty of securing modern and up-to-date machinery and equipment, and the scarcity of scientific and technical workers which render the cost structure of the project comparatively higher than the cost of those other countries. May scarcity of scientific and technical workers and lack of raw materials sa mga underdeveloped countries including the Philippines. Ang mangyayari is tataas yung cost structure of the projects comparatively higher than the cost of those in other countries. So, dahil yun nga, kulang yung raw materials, bibili tayo sa mga ibang countries and tataas yung expenses or cost structure of the project. So, yun lang. So, while it may be alright to provide incentives and protection even to high-cost industries, as long as there is a good prospect that such a high-cost condition is only temporary and justifiable, it is quite obvious that their permanent protection can be given at the expense of the people's living standards. The role of scientific study in the appraisal of the factors that will determine desirability as well feasibility of projects cannot be taken for granted. So kahit sa high-cost industries, okay lang mag-provide ng incentives and protection as long as yung cost condition is only temporary and justifiable. Kasi obvious naman na yung mga permanent protection ay kaya naman ng mga tao sa high-cost industries. So next is, too often, industrial development in the Philippines takes the form of assembly of parts imported from abroad. In many other cases, where actual processing is done locally, the bulk of material has to be imported. So while it is true that this trend is industrial development is justifiable in some situations, it is also true that there have not been enough projects built around local resources, including the disposable waste and byproducts of existing and agricultural enterprises. Scientific researchers in the past have been already shown that such diverse consumers such as goods, buildings, food, clothing, fuel, paper products of coconut, sugar, abaca, rice, and some other farm products. This research should have been carried further until the exploitation of local materials become both economically and commercially viable. So, ito nga, kailangan mag-focus tayo dito sa mga sino yan? Ito, diverse consumer goods such as building materials, food, clothing, fuel, paper products, coconut, diba? Kailangan natin exploit to para maging commercially viable at umunlad yung economy natin. So, yun nga. So, in a country's mastering support of any program for economic development, the presence of trained manpower is an indispensable factor. This factor is a major stumbling block in the potential development of many countries. Yet, it sometimes happens in the Philippines that the skills of and the training of many technically trained persons acquired at high cost go to waste because of the failure to secure employment. This condition arises because scientific and technological training is done without considering the scientific economic development programs. Otherwise, the Philippines will be faced again with the dilemma of having trained scientists and technologists who can find no useful employment for their scientific training, while the nation development is hindered by the lack of training personnel necessary for the preparatory work planning and implementation of each development program. So, ayun nga, yung Philippines is medyo malaki naman siyang country. So, madaming mga tao. So, madami din ng mga trained manpower. Pero bakit ganun? Nagkukulang pa din. So, meron tayong potential na maging malagong country. Pero dahil sa failure to secure employment, yung mga trained manpower natin is pupunta sa ibang bansa. So nawawala yon. So hindering the preparatory work, planning, implementation for development program. So, hindering yung paglago ng economy ng Philippines.
Now let's talk about the Filipino scientists, investors, and technologies. This section showcases some of the great Filipino men and women in the Philippines and international science and technology landscape, who pioneered unique and indigenous inventions with a focus on their contributions toward nation building. The first inventor is Felipe F. Siron Sr. Who is Felipe F. Siron Sr.? He was from a poor family and strived to become an inventor to help the Filipino farmers in their fieldwork and spent his time building an invention inspired from the Landmaster power tiller of England in a small shop in city of Iriga. Dito, si Felipe Siron Sr. nagsimula siya sa paggawa ng mga hand tractor materials na mula sa Landmaster na galing sa England. And then hanggang sa makagawa siya ng sarili niyang hand tractor, which is yung kanyang invention. Ginawa niya itong na mas mura para mas maraming mga magsasaka ang makabili and then makagamit nito. Ginawa niya ito dahil unang-una namuhay siya sa mahirap na pamilya, and then nagpursige siya para ma-invento nga yung tinatawag na hand tractor. Siron Sr. is also the first Filipino-made tractor named Siron Hand Tractor. Was invented in May 22, 1973, presented in Philippine Investor Commission during the Investors Week of 1973 in Manila. Dito, matapos makilala ng Philippine Investor Commission yung invention ni Siron Sr., which is yung hand tractor, dito nagsimula na silang mass produce ng hand tractor para mas makatulong ito sa mga magsasaka and then mapadali yung kanilang mga trabaho. Felipe F. Siron Sr. is currently owns the Von Machinery that provides farming equipment such as hand tractor, fodder, chopper, cultivator wheel, and roller clutch. Von Machinery later worked on the improved axial flow thresher, where the straw is separated and thrown upwards, and was submitted to National Grain Authority or NGA of Cabanatuan. Dito, yung tinatawag nilang improved axial flow thresher, ito yung ginagamit nila para maiwasan yung pagbabara ng dayami o yung nakukuha sa pagsasaka, para hindi ito bumara sa loob ng makina.
And so, Eduardo Carrion San Juan, more known as the Space Junk Man, the high-end projects Dr. San Juan had worked on were the Polaris Missile, Skyla Interballistic Missile System, and the Lunar Rover. So, Eduardo Carrion San Juan, he was the man credited with the invention of the Lunar Rover used in the 1971 Apollo 15 moon exploration. Its prototype was reportedly built out of scarp. So, Eduardo Carrion San Juan, he was also part of the Skylab project, which was utilized for long lunar orbit missions together with the Lunar Surface Base. So, the Skylab consisted principally of the Saturn workshop and the Apollo Command and Service module, which carried the astronauts to the workshop proper and was tightly docked into it. So, attached to the workshop proper were an airlock, a multiple docking adapter, and an Apollo telescope mount. So next is Dr. San Juan was also instrumental in the following classified projects. So here are the following classified projects: the neutron particle beam weapon experiment, the preparation of concept design guidelines. So next is the space surveillance and tracking system, conceptual design of the telescope, payload, and spacecraft. Next is the space-based laser conceptual design and system engineering of space battleship system. Next is high-energy laser weapons utilizing chemical laser systems. Next is the homing overlay experiment, conceptual design of missile interceptor and warhead. Next is the experimental painter and tracking, conceptual design and construction of laboratory equipment and experiments on high-energy lasers. And next is the large optics demonstration experiment, optical and sensor technology enhancement for laboratory demonstration, and last is the hot spot tracker tracking of energy threats and placing laser beams on target threats. So later on, Mapua Institute of Technology bestowed on him an honorary doctorate for his exemplary achievements in science.
Next inventor natin is Oscar B. Verona. His first presidential award was from Inventors Week, April 1970, named an electronic fire and burglar alarm with fill path number 4836. Then, his second presidential award was from his invention, a process of making vegetable food products with meat-like structure and flavor, with field path number 5615 in March 1971. Ito, yung pangalawang invention ni Oscar B. Verona, which is yung tinatawag niyang artificial meat, which is hindi ito tunay na karne. Ito ay pinaghalo-halong mga iba't ibang ingredients galing sa mga gulay para gumawa sila ng artificial meat, and para yung texture niya is as same as sa totoong karne, and then yung lasa niya ay medyo almost the same na din dun sa totoong karne. Oscar B. Verona spent 3 years on creating a non-cholesterol vegetable meat and was mass-produced 50 kilos per day. Ito naman yung tinatawag niyang vegetable meat is yung ito ay mataas sa protina kung saan nakakain ito ng mga vegan, which is yung mga hindi kumakain ng tunay na karne. Halimbawa na lang ng artificial vegetable meat is yung bacon na gawa sa gulay. Ito ay yung sinasangkapan nila ng mga iba't ibang ingredients mula sa mga gulay, sa mga natural ingredients. Ito ay then ginagamit nilang pangluto is yung air fryer, hindi sila gumagamit ng mantika para maiwasan nila yung masyadong pagkain ng cholesterol. He was also a recipient of the Philippine Legion of Honor for inventing alcohol attachment to weapon carriers in 1951 at the Philippine Army Research and Development Center.
So, next is Roberto V. Celis. So, inventor Celis wanted to move out of the Philippines because nobody supported him, not even the government, which should be sponsoring worthwhile projects. He explained that accounts of tragic sea accidents and unnecessary deaths motivated him to undertake the Unsinkable Best project. So, making use of his inventive mind, he produced the exact plans for the unsinkable boat. The big break finally came in 1978 when the press office of Camp Aguinaldo took note of his plan. He was invited to show his other inventions to the military top brass. He later submitted a scale of 5-foot-long model in the same year and installed a remote-controlled engine. Attorney Eduardo Tan of the Filipinas Foundation Incorporated or FFI tested the model and it worked. A year later, the FFI approved the project and completed work on the prototype called Dama Filipina, the first unsinkable boat. So, the unsinkable boat offered a smooth, pleasant ride without any of its passengers getting seasick. The other advantage of the boat is that it travels with less resistance when it goes into full speed, so which is important ngayon para um, less fuel less fuel na magagamit. So the bottom curvature gives its planning effect. Yun nga. So later he became the proud owner of a modest engineering company that specialized in tools and dies for export. He manufactures specialized knives for rubber world, which are utilized to cut shoes for mass production. He has also considered putting up a corporation to mass produce his unsinkable boat. So next is Sopronio M. Cian. So Sopronio Cian, yan, after a decade of continuous studies, Cian had four inventions: the portable mini cone rice mill that made him famous. He accomplished the design after a couple years of work because he did not have any drawing table. Cian had to make use of their dining table as his drawing board. The process went on until the early hours of the morning. Alone, Cian tried to make cone-type rice mill without any elevators, shifters, separators, and power transmission assembly. So his cone rice mill has only two moving parts: a main shaft for turning the huller and the cone polisher, and an auxiliary shaft for rotating both blowers. Two rotation hand wheel controls the adjustment in the milling process. It can dehullerize has up to 90% of the total amount without any grain breakage. Moreover, it only takes a maximum of 3 men to carry the 153 kg unit. Being so portable and compact, Cian's invention was nicknamed "Nonopac" by his business colleagues. It can also be called the instant mill because it can be assembled within 1 hour compared with the traditional cone rice mill which takes 6 months to build. Lastly, it has capacity of 60 to 70 cabans of rice for 12 hours of non-stop operation and a grain recovery rate of more or less 67% higher than the recovery rate of the Kiskisan type of rice mill, which is only 45 to 50%. So nowadays, the Nonopac is being mass-produced and is covered by the Patent Utility Mode number 627 issued by the Philippines Patent Office. The machine has been put to the test by rice mill expert Harry Van Rieten of the United Nations Food and Agriculture Organization many times. And this is what he said on Cian's invention. The recommended improvements having been completed, the improved Nonopac has great economic value as an alternative to the Engelberg type huller. The recovery rate is greater, the rice quality is higher, and the power required is lower.